Hey fellow classmates, this is Samantha. I know that my video is a little late this week, so I hope that I'll still get a comment on it or two. Anyways, I decided to do number 4 from section 10.5, which was the section on the ratio and the root tests, respectively. I chose number 4 out of 10.5 because I think that you can use either test to solve whether this series will converge or diverge, or if the test is inconclusive. So the way that the homework did it, if you look at the show me how to do this problem section on Math Lab, use the ratio test. But I solved this problem using both the ratio test and then the root test. So let's start with the ratio test. So we have the sum from n to infinity of n to the square root of 2 over 2 raised to the nth power. So what I'm going to do first is I'm going to do rho is equal to the limit as n goes to infinity of n plus 1 to the square root of 2 over 2 to the n plus 1 power divided by n to the square root of 2 over 2 to the n. So this first section is just the n plus 1, and then this is just the original a sub n. But I want to rewrite this as a multiplication problem because it's easier to cancel that way. And it's kind of easier, I think, intuitively for the brain to see how things cancel when you write it this way. So I've got n plus 1 to the square root of 2 over 2 times 2 to the n times the fraction 2 to the n over n to the square root of 2. So as you can see, the 2 to the n's cancel, and that leaves us with n plus 1 to the square root of 2 over 2 times 1 over n to the square root of 2, which what we can do is we can take the 1/2 out, and then we just, since they're both n and n plus 1 are both raised to the square root of 2, we can just write that as a fraction all raised to the square root of 2. So that leaves us with 1/2 times n plus 1 over n square root of 2, which we want to rewrite as 1/2 times 1 plus 1 over n, that raised to the square root of 2. Here we just simplify the n over n and then the plus 1 over n. So the n's cancel and give you 1. And then as n goes to infinity, 1 over infinity we know goes to 0. So it's just going to be 1/2 times 1 plus 0 raised to the square root of 2. And 1 raised to the square root of 2 is simply 1. So 1/2 times 1 is equal to 1/2. And that is less than 1. And so according to theorem number 12 for the ratio test, the series will converge if p is less than 1, and p in this case is less than 1, so this converges. Moving on, but could we have used the root test? So the second part of 10.5. And I may be wrong here, but I said yes. And so what I did is we have the sum again of n to infinity of n to the square root of 2 over 2n. We're going to write that as the limit as n goes to infinity of the nth root of n to the square root of 2 over 2 raised to the nth power. I like to rewrite this as n to the square root of 2 over n because the nth power is simply 1 over n. It's going to be the power, 1 over n. So we have 2 over n, and then we have that all divided by 2 to the n over n. Well, n over n is going to cancel. That's going to just give us 1. So then we're going to have here 2 to the 1th power, which is 2. So I just take that 2 out as a 1/2. That way my mind can kind of intuitively just kind of leave that out until the end. And then what we're left with is n raised to the square root of 2 over n. Now, as n goes to infinity, I believe that this was brought up in the lecture by Dressler at the end where we're supposed to figure out kind of what's going on. And that was the last example. I can kind of go over that if anybody has questions. But here we have the square root of 2 over infinity. And as n gets larger and larger and larger, that power is going to go to 0. And as n goes to infinity in the actual sort of equation here, anything raised to the 0 power is simply 1. So infinity raised to the 0 power is going to be 1. And so again, we are left with 1/2 times infinity to the 0 power, which is 1, which simply gives us 1/2. So according to the root test, the series will converge if p is less than 1. Again, we get that p is 1/2, which is less than 1. So this series will also converge. So I hope that I've kind of gone over any questions that anybody might have. This problem was sort of similar to the last example that Dressler gave in the notes, and that was the sum of n equals 1 to infinity of 2n over n to the 10th. Towards the end, once we figure everything out, we have n to the 1 over nth power as n goes to infinity. And Dressler said, think about this one. Think about why this equals 0. And let me back up so that I can kind of write the whole problem out. That way it'll make a little more sense. So we here did the root test as well. And so that was the nth root of 2n over n to the 10th, which if you kind of do what I do, I'm just going to rewrite this as 2n over n divided by n to the 10 over n. And that's going to leave us with 2 to the 1, which is simply 2, over n to the 10 over n. Now, as n goes to infinity, let's work on this bottom part. N, and then that's raised to the 10 over n. As n goes to infinity, it's going to equal infinity over 10 divided by infinity. Well, as n in our power goes to infinity, that's actually going to equal 0. So now we're going to have infinity raised to the 0, which, as I just told you, hopefully you guys aren't just believing me and you're looking into this too, or you know this as well. That's going to simply equal 1. So this whole lower part right here is equal to 1, which means that we are left with 2 over 1, which equals 2, which since P, wrong inequality sign, P is greater than 1, which means that this series will diverge. Alright guys, I hope that helped you out with some questions you might have had on the notes, questions on the homework. I hope everybody's doing well this week. I know I've personally been struggling, but I hope to get through it with all of your help, and have a great weekend.